Welcome to Chemistry Lover, and here I am with another problem. So if you are new in this channel, let me tell you that I am solving some of the difficult question of CSIR-NET exam in very easier and efficient way. So I am making this video series. I already made 3 or 4 more videos like that. So these videos are targeted for the upcoming CSIR-NET exam to give you some idea about how you can solve question in shorter time with efficient way. So I will recommend you to watch that videos by going through my channel. Now without doing further delay, let's start today's topic. So this question is from CSIR-NET exam December 2014, and if you look at the question at first sight, it will look like a slight messy problem, a complicated problem, but we have to approach this problem with a smart way, and that's how we can solve it very easily. So let us first look at all the options. So these are all the 4 options given, and basically you have to predict product A and product B out of this reaction. Now if you look at the substrate, there are a lot of sides which are reactive, but if you look at the first reaction condition, it is TBAF or tetrabutyl ammonium fluoride, that is Bu4N plus F minus. So it is basically a fluoride source. Now you have to know what fluoride does. So fluoride is a very good binding agent for silicon, and if you have any silicon moiety in your substrate, the fluoride will always attack on that silicon. So here this fluoride F minus will attack on this silicon to give you one negative charge over here. So what you will get is this thing. So here you have this N, this SPH, and you have this negative charge over here, COO2Me. This ester group is over here. So this is the first step. You can see a lot of reactive centers are there, but only this center will react because fluoride is selective for silicon. Now you have this anion in your hand. Now you can see this anion is conjugated. So this is a conjugated system like this. So you can look at this system like this one. So here you have this and this minus. So this sort of system is there. You can see this is fully conjugated. This is fully conjugated, and in any fully conjugated system, it is the 2 terminal position, this position and this position, they are the reactive centers. Whenever any attack will occur, it will occur from this terminal center and not from this inner center. So you may think that when this negative charge push, it can attack from here, but this is not a good way of attack, because if you look at the orbital coefficient, the orbital has the highest coefficient at this terminal and very low coefficient at this middle center. So that's why the reaction will always take place from these 2 terminal, right? And in terms of charge accumulation also, these 2 terminals are more of negative charge. So that's why any sort of attack will take place from this center and this center. Now let us look at the electrophile given. So it is the electrophile here. So you have 2 centers, 2 electrophilic centers, but you may easily rule out this possibility because its electron deficiency is reduced by the oxygen lone pair of these 2 oxygen. So that's why this center is much better electrophile than this one, because it is more electron deficient or more reactive, and that's why any sort of nucleophile will attack over here. Right now this is not a problem here, because you will see in all the cases the attack is taking place over here. Now if you look at option 4, you can see it is a very wrong product, because it will only arise out of coupling reaction, or basically it is showing that the reaction is occurring at this site. So this nucleophile is attacking over here, but this is not a electrophilic center, this is not electrophilic center, and that's why we can easily rule out the possibility of option D, because it is not electrophilic center and no reaction can occur here. And also you can see one carbon atom is also missing. So this is a properly a wrong product. This is a wrong product. Now we are left out with three options: option A, option B, and option C. In option A, you can see the reaction occurs like this. So this conjugation happens, this negative charge push here, it goes here, and then the attack take place from here. So attack take place from nitrogen, and that will give you this option A. You can see from the attack from here, this nitrogen. So if negative charge over here, so it will go like this, and from this nitrogen the attack is taking place over here, this will go, and you will have this product. So we have option A. In option B, on the other hand, you can see the attack is taking place through this center, this inner center, and we already told that this center is not that much nucleophilic because HOMO has low coefficient, and also the negative charge density is also lower. So that's why we can also rule out option B. So option B is ruled out. Now in option C, you can see the reaction is taking place through the original negative charge center, or the origin of the negative charge. You can see it is the original center which has the negative charge, and if the attack takes place from this center, it will give you this A product of option C, right? So we now have only option A and option C for our potential answer. Now let us look at the second reaction, second product B. Now in product B option, you can see this is the product B for option A, and this is the product B for option C. Now if you look at option C, so this product, how it can form, so you can see there is no such explanation, nice explanation, that how this product can be formed. And you can see this is 1, if you number 1 2 3 4 5 6, so it is showing that a bond is formed between this nitrogen center and this oxygen center. So you may think that this nitrogen lone pair can attack over here, but let me tell you that this is sp2 nitrogen and it is not that much nucleophilic, so its lone pair has lower energy, and this type of attack from imine is very less common. So this attack is not that much common, and you can rule out this possibility. But if you look at option A, you can see this center, these two center, if you look at this particular segment, it is a arrangement like so. If I draw it properly, so this is what it is. So you have this nitrogen over here, this is the benzene ring, and here you have this. So let me draw it properly. So it is double bond, another double bond over here, NCO2Me, and here you have this nitrogen, this SPH, now this CO2Me, this. Now we can place it over here like this, and then we have this. How many carbons are there in between? This is 1 2 2 carbon atoms are there. So this is 1, this is 2, and this is the ethyl. So now you can see this is segment, this segment is a diene, and this is a dienophile. So a very nice Diels-Alder type reaction can occur, and out of this Diels-Alder reaction you will get this product B. And if you look at the product, there are some stereochemical things is there, but you don't have to bother about stereochemistry because only one option is there and it has to be like this. So this product looks a wrong product because this type of reaction is not popular, and you can see if this attack happens here at all, but after that you can see how can this this carbonyl group can again be regenerated because there is no oxidizing agent, right? So this is not a correct option. So we are only left out with option A, and this option A will give you the correct product. So option A will be the correct answer. Now you can see at first sight when we approached the problem looks like a quite difficult problem, but if we have seen that if we proceed the problem with logical approach, you can solve it very quickly. So we have seen that with the right approach we can solve a difficult problem. So that's what I wanted to tell you. I hope that this video will help you. Thank you for watching.